Section 6.2, trig functions and real numbers. The first 2 pages of this is review. Keep in mind you can use your unit circle, but please don't use your calculator to figure these out. So I'm going to go through just a couple on this page, and then you're going to go back and fill it out. Same thing with the next page. Just give you some examples, and then you can fill the rest out yourself. And then the last 2 pages we'll go through thoroughly. Or I'm sorry, the last page. Okay, so if we start with number 1, it's simply saying, what is the value of sine at pi? So if I look at my unit circle, at pi, I have the point -1, 0 at pi. Well, knowing that we have cosine, sine for each of these ordered pairs, my answer for this would be 0. Then if I did the same thing at cosine at pi over 2, I have the point 0, 1. Since I want cosine, this one is also 0. Now, if I enter a different quadrant and I look at 5 pi over 4, which is in quadrant 3, I'm going to have a negative value. And when I go to that point, I have negative square root 2, negative square root 2, and the sine value is therefore negative square root 2 over 2. So you're going to go through each of these problems and do the same thing. If we look at a problem like number 11, negative values also take us in a different direction. So negative pi means that on the unit circle we're going to go this direction, but we do still end at that -1, 0 point. And since we're asking for cosine, that's the first number, so -1 is our value here. For the next one, sine at 4 pi, you have to use your coterminal angles, so make sure that it is in between 0 and 2 pi. So if you subtracted 2 pi, the coterminal angle would then be sine of 2 pi, which is going to be the same value of sine at 4 pi, since that's what coterminal means. So at 2 pi, all the way around that circle, we have 1, 0, so our sine value is 0. Okay, so if we were to skip down, the last one I want to do is number 16. So if I did negative 2 pi over 3, you can approach this in 2 different concepts. You could use coterminal angles and take negative 2/3 and add 2 to it, which is going to give you 4 pi over 3. So instead of going negative on the unit circle, you could just go all the way around to positive 4 pi over 3. But it is good to know that negative implies a direction. So if I know that this is where I land out of the 3 points, I land right here is 2 pi over 3 going to the right. I'm sorry, not the right, going counterclockwise as a positive. If I did the same motion but went negative this direction, then I'm going to end at this first point down here. So it's the same distance, it's just going clockwise, and this is where we get 4 pi over 3. And at 4 pi over 3, our sine value is negative root 3 over 2. So you could use coterminal angles, or you can just go the distance that it's giving you, but just keep in mind negative is clockwise and positive are counterclockwise. Okay, so on that next paper, again, it's asking the same thing of you essentially, but for some of these we have to do a little bit more work. So if we went down to tangent of 7 pi over 6, I want to know what value is this. So tangent, we know, is sine over cosine. So I need to go to 7 pi over 6 and get those 2 values. So if I did that, I get negative 1/2 over negative root 3 over 2. So we are going to change this division problem into a multiplication problem. So we're going to multiply it by the reciprocal. So this is going to equal negative 1 over 2 times 2 over negative root 3. All right, so let's simplify. Well, I can simplify the 2's right here, and then I'm left with a negative over negative, which is a positive, and so I'm left with 1 over root 3. Well, we also know that we have to rationalize, so my next step is to multiply both by the square root of 3, which gives me a final answer of root 3 over 3. Now, on this page, I'm showing you a couple of the more involved problems. The first couple really just involve you looking at the unit circle and then simplifying, but with tangent and some of these inverse functions, we need to actually do a little bit more work. So, for secant, you have to remember that secant is 1 over cosine. So, before I begin, I'm going to do 1 over, and then I'm going to go to cosine and write that value at 11 pi over 6. So cosine at 11 pi over 6 is root 3 over 2. So again, I'm going to write this, well, 1 over is asking to do the reciprocal, so we have 2 over root 3, and again, we do have to rationalize. So this is going to become 2 root 3 over 3. And then if we looked at 30, this one's very straightforward. I want just the cosine value of 2 pi over 3, which is in your second quadrant, so the answer is negative 1 over 2. So you have to do a little bit more work with some of the inverse functions, but for some of them, it's just as simple as what we did on the page before. Okay, so if we went down to 34, the first thing that we need to do is make sure that we can get this positive. So you can apply the coterminal, so negative pi over 6 plus 2 pi, which is 12 pi over 6, gives you 11 pi over 6. So really I want to know cotangent of 11 pi over 6. Again, you don't necessarily have to do this work that I showed you right here. If you know that if you know how to move on the unit circle and you go clockwise that same distance of pi over 6, then you will end at 11 pi over 6, so that is fine as well. So now that we know we're focusing on 11 pi over 6, what we're going to do is figure out cotangent. So cotangent is, you could say 1 over tangent, but the easiest way to do it, since the unit circle gives us only our sine and cosine functions, is to say that since tangent is sine divided by cosine, cotangent is cosine over sine. So at 11 pi over 6, cosine is root 3 over 2, and sine is negative 1/2. So if we took this division problem and we wrote it as multiplying by the reciprocal, we have root 3 over 2 times negative 2 over 1. So the 2's simplify or cancel out, except that negative stays, so our final answer is going to be negative root 3. And again, 35 is actually one that was from that front page. Negative 2 pi over 3 has a coterminal angle of 4 pi over 3. So that's the value of sine that we're looking for, which is root 3 over 2. So again, some of these might be simple, some of these might involve a little bit of work. Okay, so the last two I want to show you are sine of 8 pi. Well, if you know how to move on the unit circle, you could do it that way, or you can find your coterminal angle. So since coterminal means that you're going to subtract 2 pi each time, then 2 pi goes into 8 pi 3 times. So I would do 8 pi minus 2 pi, which gives me 6, minus 2 pi, which gives me 4, minus 2 pi, which gives me 2 pi. So this is in the unit circle, and then what's sine at 2 pi? 0. And then for 40, the same thing applies, except since it's negative, if you add 2 pi to it to find the coterminal, to get it to be positive, then the first thing that happens is it adds to give you 0. Well, 0 pi, or 0, is a value also on the unit circle. So cosine at 0 is 1. Okay, so if we go back and we review the inverse trig functions and their range restrictions, we're going to relate it to the unit circle. So if you remember, for sine, we had the value, we were in quadrants 1 and 4, where quadrants 1 was positive and 4 was negative. So if I went straight to that example below it, the arc sine, which is sine inverse, at negative 1/2 is going to give me a negative value. So we're in quadrant 4. So we're actually going to go negative pi over 6. Then for cosine, we were in quadrants 1 and 2, where 1 was your positive cosine values and quadrant 2 was your negative cosine values. So if I gave you, this one was the hardest one because you had to do a little bit of subtraction. If I said, you know, go to cosine where you have root 3 over 2, then you would get pi over 6, but you'd have to find the negative value of that and subtract it from pi. So you did pi minus pi over 6, and this is where we went and we said 5 pi over 6. And this was the only quadrant that gave us a different value other than the positive or negative of the reference angles. So then with your tangent, the only other exception was that you couldn't have a value at on the y-axis because you would get an undefined when you did sine divided by cosine. But your positive tangent values were in quadrant 1 and your negatives were in quadrant 2. So if I asked for negative 1, where tangent is 1 is at pi over 4, but since it says negative 1, we can say negative pi over 4. All because of the range restrictions of these graphs. So we're going to use these along with our unit circle to solve simple trig equations. So all of them, t is going to be on 0 to 2 pi, so make sure that we are in that range. Okay, so now what we're doing is we're going to use reference angles to find the two angles where cosine is negative 1/2. So again, the first thing we're going to do, since we're trying to find an angle, is determine in what quadrants do we have a negative cosine value. So those two quadrants are 2 and 3. So both of my angles from the unit circle need to be in quadrants 2 and 3. So going back to my reference angle, since on the unit circle you're going to get on the test, it only has quadrant 1 filled out for your cosine and sine values, you're going to find the reference angle. So sometimes you'll see me say TR or TREF, the reference angle. So if I use that unit circle, not the one we created in class where everything is filled out, then cosine is 1/2 at pi over 3. But this isn't helpful because I don't want pi over 3 in the first quadrant. I want the other two. So if you remember, in quadrant 2, what we did was we said, okay, take pi and subtract your reference angle, which is 2 pi over 3. And in quadrant 3, we would add it, which is 4 pi over 3. So these are the two spots on the unit circle where we have a cosine value of negative 1/2. For 49, we have positive sine. So where's sine positive? Well, we have sine can be positive in quadrants 1 and in quadrants 2. So in this case, my reference angle of quadrant 1 is going to be one of my answers because I want to be in quadrant 1. So on your chart, where is sine? Where is sine root 2 over 2? And that's pi over 4, so you could call this your reference angle as well. And then to be in quadrant 2, we took pi and we subtract pi over 4, which gives us 3 pi over 4. Okay, so we can get a little bit more complicated with some of these problems as well. So if we look at 46, we have cosecant of 2 root 3 over 3. Well, this isn't so easy to just see, so we have to do a little bit of work. So we're going to take cosecant and we're going to make it into our original trig function sine. So to do that, what I'm going to start with is saying, okay, well, sine is 1 over this. So that's going to give me 3 over 2 root 3. Well, we do have to rationalize, so I'm going to multiply by root 3 over root 3. And I'm going to end up with 3 root 3 over 2 times 3. And 2 times 3 is 6, or we do 3 over 6, or right now we can simplify and say, okay, now we're looking for where sine is root 3 over 2. So after figuring out that, and now we have that value on the unit circle, we're going to say, okay, now sine's positive in quadrants 1 and in quadrants 2. So my first quadrant, or my reference angle, however you choose to note it, if I just look at my unit circle, is pi over 3. So then to be in quadrant 2, we take pi and we subtract our reference angle, and we end up with 2 pi over 3. So these are the two angles on our unit circle where cosecant is 2 root 3 over 3, or you could even say where sine is root 3 over 2. For 50, secant is 1 over cosine, so this means that cosine of t also equals 1, because you would do 1 over 1. So now we're looking, okay, where is cosine 1? Well, there's only one spot on the unit circle where cosine is 1 between 0 and 2 pi, so our answer is just 0. At 0 pi, or however you want to say it, at 0 is the only place on our unit circle where cosecant, where cosine is 1. The other spot where we have cosine 1 would be negative 1, not exactly 1. So there's only one spot. That's your quadrantal angles when they're on those axes like that. Okay, so then again, for cotangent to be negative 1, that means that tangent, sorry guys, tangent would be 1 over negative 1, which is still negative 1. They see something outside. I don't know what it is, so I'm sorry. All right, so now I'm saying, okay, well, where's tangent negative 1? Well, first off, tangent is negative in quadrants 2 and in quadrants 4. So where do we get those values? Well, looking at the unit circle, tangent is sine over cosine. Well, for them to be 1, they have to be the same thing. So your reference angle is going to be pi over 4, because that's where we have sine and cosine equaling the same thing, root 2 over 2. And now it's just a matter of getting the signs, SIGNs, correctly. So to be in quadrant 2, we're going to do pi minus pi over 4 and get 3 pi over 4. And then to be in quadrant 4, we're going to do 2 pi minus pi over 4, which gives us 7 pi over 4. Okay, so for tangent to equal root 3, we need to know where that comes from. Well, this is where we have sine being root 3 over 2 divided by 1 over 2. Because if I simplify that, I'd get root 3. So now this might help a little bit then to say, okay, well, tangent, I could have done this first. Tangent is positive in quadrants 1 and 3. And so I'm looking now for a sine value of root 3 over 2 and a cosine value of 1/2. And that angle is in quadrant 1, which is one of the quadrants we need, at pi over 3. And then to be in quadrants 3, we're going to take pi, and we're going to add pi over 3 to it, which gives me 4 pi over 3. Okay, so for secant to be undefined, this means the only way we can get undefined on the unit circle is to have 0 in the denominator, and 0 is always paired up with 1. So it would be to give me 1 over 0. Well, where does this happen? So 1 over 0 is for secant, so that means secant, since it's 1 over cosine, that cosine of t therefore is going to give you 0 over 1. So now we're asking, okay, where is cosine equal to 0? And those two values are pi over 2 and 3 pi over 2. Again, your quadrantals on those axes. Okay, and our last one is where tangent is 0. So tangent can be 0 in two separate places. We can have that be 0 over 1, or we can have 0 over -1, because both give us 0. So the two places where we're going to have tangent equals 0 is when we have sine being 0, because tangent is 0, or sine over cosine. So sine is 0 at 0 pi, or 0 degrees, and then it's also 0 at pi. So when you do sine divided by cosine, that's going to give you the 0 over 1 and -1.